Man, I feel like I'm forgetting something. Like, maybe it's not important. Parametrics, calculus, college board, AP. Oh man. Oh, what the? Man, that was a terrible nap. Like, it was awful. What the? What are my neighbors up to? Let's take a peek. Okay. You're studying calculus? Okay, alright. When calculus calls, heed the call. Art of war, Sun Tzu. So, hey everybody, welcome back to my YouTube channel. My name is Zarius, and today I'm going to be teaching you my speedrun route to getting a 5 in AP Calculus. And the problem we're doing today isn't that hard. I believe in you. I know you have it in here somewhere, and let's get to it together. Alright, so this is the problem that we're going to be looking at. First, I just want to read it through together so we know what we're getting into. At time t is greater than or equal to 0, a particle moving along a curve in the xy plane has position xt, yt with velocity vector vt is equal to cosine t squared and e to the 0.5t. At t equals 1, the particle is at the point 3,5. Okay, so let's highlight some of the important things that I think most of us tend to miss, right? First of all, at t equals 1, the particle is at the point 3,5. This right here is your initial condition, and it's very important because, well, as you see in the first question, we'll need to use it, so don't forget that. Second of all is that we're looking for VT. We're looking at VT here, so this is not a position function, this is a velocity function. So we have to keep that in mind because velocity is the derivative of the position, right? So we want to make sure we're not finding the derivative of the derivative, and then we'll get the whole thing wrong. All right. Okay, let's look at part A. Find the x-coordinate of the position of the particle at time t equals 2. Okay, the x-coordinate refers to the position xt right here. So what we want to do is look at our function that is given to us. This is a velocity function, and we're trying to find the position, which means we have to take the integral. But let's stop for a moment. Let's not get too hasty, right? We're trying to find x2. We have an initial condition, and we know that at t equals 1, the particle is at the point 3 and 5. And so, using a fundamental theorem of calculus, we know that from 1 to 2 of the integral from 1 to 2 of xt dt, or well, we're actually going to write that out so it makes it a little bit easier for us. Cosine t squared dt right? We know that this is equal to x2 minus x of 1. And since we're trying to solve for x of 2, and we know x of 1, right? X of 1 is equal to 3. We can rewrite this as x of 2 is equal to x of 1, or 3, plus the integral from 1 to 2 of cosine t squared dt. All right, this is a calculator question, so you will need your calculators for this. I'm gonna go grab mine really quickly. And what we should get is 2.557 if you round, and 2.556 if you truncate it. All right, let's look at number at B. For 0 is less than t is less than 1, there's a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? Okay, we are looking for time now, and we know that the slope, right, m is equal to the derivative, which is equal to dy over dt over dx over dt. It's very important that you guys don't mix this up and put dx over dt over dy over dt. That's also a pretty common mistake. Yes, and recall earlier that I said to pay attention to the function given to us. In this case, it's the velocity, which is already dy over dt and dy dt and dx dt. So since we have them, we don't really have to take the derivative. We should not take the derivative of the velocity, and we just write e to the power of 0.5t over cosine of t squared. All right, now that we have this equation, we can go ahead and set it equal to 2, because we know that this dy dx is equal to 2, because that's the slope. And to solve this, you can either use the solve function on your calculator, or you can find where they intersect. Me personally, I use the solve function, but we have to be very careful that our answer is within the bounds, right? We are given the bounds from 0 to 1, so t cannot be less than 0 and cannot be more than 1. Let's go ahead and plug that into our calculator really quickly. Get t is equal to 0.840. Right, if you don't know what the solve function is, it's this thing right here. And let me see if I can get to focus. Right there. And to get to this, you wanna press math right here, and then you press up, so it leads you to the bottom, and it should be the very last function right here, numeric solver. You press enter, and it gets you to here. All right. Moving on to C. Now it's asking us to find the speed. We know the formula to find speed, right? Speed is equal to the square root of dx over dt plus dy over dt. And remember that these values inside are squared. That's pretty easy to lose track of. Just make sure you don't do that. And we have the value of dx over dt and dy over dt. I actually forgot to write them in question B, but I would suggest writing out dx over dt and dy over dt so you don't get confused. So I'm going to write that right here. dx over dt is equal to cosine t squared, and dy over dt is equal to e to the 0.5t. So this means we're taking the square root of cosine t squared plus e to the t, because e to the 1/2 squared is just going to be e to the t. And then we know that the speed is 3, so we're going to set this. This is another solve problem. we're gonna set all this equal to 3, and we're gonna use the solve function again on our calculators to find t. And once we have that, we should have 2.196 or 2.195 if you truncate your answer. And then moving on to the last question, we're being asked to find the total distance traveled by the particle from time t equals 0 to time t equals 1. For this one, there's also another equation for this. Recall that we want to be taking the integral from 0 to 1 of the speed equation, because we know that speed is just the derivative of distance. And for this one, you just need to plug it into the calculator and you'll get your answer. And your answer should be 1.595 or 1.594 if you truncate your answer. Okay, that's it for this problem. Thank you guys so much for watching. That's it for this video. If you enjoyed, please subscribe and like, and in a bit I'll show you guys some resources. If you need some practice on this, then you should definitely practice that, and I'll see you guys in the AP exam room.